So we want to learn how to draw the Lewis structure. I think we drew for water last time when we were just learning how to draw Lewis structure. So it means that everything should be fine. If you go through it very fast, oxygen at the center because it's bonding with hydrogen, so it will be the central atom. So we have two single bonds already around the oxygen atom. So we need to put the remaining electrons because there are total number of 8 electrons. If you remember, 6 from oxygen and 1 each from each hydrogen atom. So making total number of 8 electrons. Out of the 8 electrons, 4 electrons are used. So we have 4 electrons left. And then the 4 electrons, they say we are going to put them on the terminal atom to satisfy their octet or duet. But this hydrogen has its duet already, so we're not going to put any electrons around it. And same thing, the hydrogen. So instead, we'll put it at the central atom. So 4 electrons, 1, 2, and then 1, 2. So if we see that double bond is needed, we will put double bond um, between the atoms that are bonding. So here there's no need to add double bond because hydrogen cannot have double bond. So this is the correct Lewis structure for water. We will see that all the 8 electrons are used already. 1, 2, 3, 4, 5, 6, 7, 8, which make this to be correct Lewis structure for H2CO. So H2CO, we need to determine which atom is going to be the central atom. And of course, carbon is the least electronegative between carbon and oxygen. So carbon will be the central atom. Of course, hydrogen will always be at the terminal. 2 hydrogen atoms, 1, 2. So we'll put them. And then 1 oxygen atom, 1, like this. So everything is fine. We put all the single bonds already. Before we do this, we are supposed to know the total number of electrons that are needed for this Lewis structure. Carbon will have 4 valence electrons. Remember, it's 2, 4 carbon because it's element number 6. For oxygen, 6 valence electrons. For hydrogen, 2 hydrogen atoms. So we are going to have 2 times 1 valence electron. So making 2 for hydrogen. So 6 plus 4, that is 10 plus 2, that's total number of 12 electrons. Out of the 12 electrons, how many have been used to make bonds between the atoms? 1, 2, 3, 4, 6 are used to make bond between the atoms. So we have 6 electrons left. Out of the 6 electrons left, we need to put lone pair electrons on the terminal atoms. This one, hydrogen does not have any lone. It doesn't need any lone pair electron. This one does not need any lone pair electrons because it needs only duets. It needs only 2 electrons to satisfy its duet electronic configuration, and then they are here already. So it means we need to put the electrons on the 6 electrons on the oxygen. So 1, 2, 3, 4, 5, 6. Everything is fine regarding oxygen. Now we have 8 electrons around this oxygen, which is fine. We have 2 electrons around this hydrogen, which is also fine, and 2 electrons around this hydrogen, which is fine as well. But for this carbon, it is not up to 8 electrons. There are only 6 electrons around this carbon atom. So it means that is not fine. So what do? We need to construct a double bond. We take 2 electrons from the lone pair to make a double bond. So we're doing that now here. So we've made the double bond. Remember, this double bond has to be converted to a single, these 2 electrons has to be converted to a single bond. So this electron, I'm converting it to a bond now, making this bond double bonds altogether. So if we count now for each atoms, each of them will satisfy whether duet or octet. Of course, for hydrogen, duet is satisfied. For oxygen, for this carbon now, 1, 2, 3, 4, 5, 6, 7, 8, this is satisfied. For oxygen, octet is satisfied. And this is the Lewis structure for H2CO. So for CCl4, let's draw the Lewis structure Of course, carbon is the least electronegative between carbon and chlorine. So carbon is going to be the central atom. But before that, what are the total number of electrons that will be needed for this Lewis structure? 4 electrons from carbon, and then we have 4 chlorine atoms. It's going to be 4 times Cl. So what is the valence electron for chlorine atom? It is 7. If you remember, chlorine is element number 17, 2, 8, 7. 7 valence electron. And then we have 4 of those 7 valence electrons. So 4 times 7, that is 28 valence electrons for this chlorine. 28 plus 4, that will be 32 electrons in total that we are using in this CCl4. So the first is to join to draw the skeletal structure. So Cl, and then Cl, 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 and this Cl. So this is fine already. So out of these 32 electrons, we use 8, 1, 2, 3, 4, 5, 7, 8 to draw the skeletal structure. It means we need to subtract those 8 electrons from 32. So if we take away 8 from 32, what do we have? What do we have? We are going to have, I don't know what we're having. So if we take 8 from, that is going to be 4, and then we have 2 left. So that is going to be 24 electrons left. Is it correct? Okay, it shows we are good to go if it's correct. So we have 24 electrons left. So those 24 electrons, the next, if you remember, the next is to put the remaining electron to make lone pairs on the terminal atom. So this is the first time we don't have hydrogen as our terminal atom. And then you remember chlorine has to be octet, not duet. So it means we need to put electrons on them to make each one of them octets, to have octet electron structure. So for this chlorine 1, 2, 3, 4, 5, 6, then 7, 8. So chlorine has 8 as well already. So we do the same thing for this chlorine as well. So we have used 12 now. 1, 2, 3, 4, 5, 6. We've used 18. 1, 2, 3, 4, 5, 6. 6 times 4, 24. It means we've used all the 24 electrons to satisfy octet for the chlorine atom. So chlorine, they are octet already. So this is fine. This is fine. This is fine. This is fine. What about carbon? Of course, you can say that carbon has octet electrons as well. It has octet electron configuration because there are 8 electrons around carbon atom. 2 electrons for each single bond. So it means that this is also satisfied. So this is the Lewis structure for CCl4. What about for ammonia? The central atom is nitrogen. The skeletal structure is this. And then the total number of electrons needed for this bond, if you remember, nitrogen will be 5 electrons and hydrogen, 3 of them, going to be 3 electrons because 1 for each. So we have 8 electrons needed for this total number of 8 electrons needed for ammonia, to draw the Lewis structure for ammonia. And then out of those 8 electrons, 6 have been used already to bond between nitrogen and hydrogen atom. So we were told to put extra electron on the terminal atom, but our terminal atom is hydrogen, so hydrogen has 2 needed electrons already, so we are not going to put electrons on it. Okay, remember we have 8 total number 8 electrons needed for this bond, this structure, and 6 has been used. So it means we will have 2 electrons left, and the 2 electrons left, we can put it on any of this hydrogen, and because hydrogen has its duet already. What about nitrogen? Nitrogen does not have duet yet. It has only 6 electrons around it, so the remaining 2 electrons will go for nitrogen, like this. So this is the Lewis structure for ammonia.